All right, this next section we're going to be talking about matrices. A matrix is a way to organize a bunch of numbers, or could even be words, anything, but it's a way to organize them. A matrix is made, looks like this. A matrix is made up of rows, which are horizontal and go across, and columns, which go vertical, go down. So like this is row 1, row 2, row 3. Going down column 1, column 2, column 3. The little subscript numbers tell you where that term, each one of these is called a term, where that term is located. So like here, that looks like it says A13. What that actually means, the 1 means it's in row 1, the 3 means it's in column 3. So if I would ask you to find the entry that's in row 3, column 2, you would look for A32. So that would be A32, row 3, column 2. That's what the little subscripts represent. One of the first things you talk about with matrices are their dimensions. For the dimensions, you always take the rows times the columns, the rows by the columns. So like this is a 3 by 3 because there are 3 rows and 3 columns. Anytime the rows and columns are the same, that's called a square matrix. So a 1 by 1, a 2 by 2, a 3 by 3, a 4 by 4, those would all be square matrices. So if we were first finding the dimensions, we just go through and count the rows and count the columns. Like this one here has 2 rows, 2 columns. So this is a 2 by 2. This one has 2 rows, 3 columns. So it's a 2 by 3. C again has 2 rows, 2 columns. It's a 2 by 2. D has 2 rows, 3 columns. It's a 2 by 3. E has 3 rows, 2 columns. It's a 3 by 2. So one of the first things you do when you look at a matrix is look and see what the dimensions are. If two matrices are equal, they must have the same dimensions, of course, and their corresponding entries have to be equal, which kind of makes sense. If we want to add and subtract matrices, they must have the same dimensions. So you can add a 2 by 3 to a 2 by 3. You can add a 4 by 4 to a 4 by 4. If they don't have the same dimensions, you cannot add or subtract. Like here, if we wanted to take down here A plus C, well, A is a 2 by 2, C is a 2 by 2, so we can add those together. All you do is add the corresponding entries. So up here, if I just wrote them out the long way, we'd have 1 plus 1, 3 plus 2. So you just add the ones that are in the corresponding parts. Negative 1 plus 9. 0 plus negative 1. Kind of how you would guess. If you didn't know any better, it's how you would try to do it. So we would come up with a matrix that's 2, 5, 8, negative 1. Or if I wanted to do C plus E. So you look at the dimensions first. Well, C is a 2 by 2. E is a 3 by 2. Well, their dimensions don't match, so that's not possible. Again, the dimensions have to match. Here, D minus B. Well, D is a 2 by 3. B is a 2 by 3. So there, we're okay to subtract. So we just take every entry from D and subtract its corresponding entry from B. So that'd be like 7 minus a negative 1. Negative 3 minus 5. 0 minus 2. The second row would be 0 minus 0. 1 minus 4. 5 minus 7. So if we simplify those, you'll see 8, negative 8, negative 2, 0, negative 3, and negative 2. So we started with 2 2 by 3s, we ended up with 2 2 by 3s. Now, if you multiply a matrix times a number, not by another matrix, but by a number, that's called scalar multiplication. We'll do the same thing when we talk about vectors later, because you're multiplying by a number and not another matrix. That's why the term scalar is there. A scalar is not a matrix, it's just a single number. All you do is distribute that number, just like the distributive property. So if we had negative 4e here, we're going to take every element of matrix E here and just multiply it by negative 4. So negative 4 times 1, negative 4 times 0. Make sure you put them in the same spot they were. Negative 4 times negative 3, negative 4 times 1, negative 4 times 2, negative 4 times 2. That's all there is to scalar multiplication. Now comes the tricky one. The tricky thing with matrices is multiplying matrices. First of all, it doesn't necessarily matter if they have the same dimensions. The first thing you want to do if you're asked to multiply matrices, like if we're multiplying here A times C, is write down the dimensions of A, 2 by 2, write down the dimensions of C, 2 by 2. What we're looking for is these middle two numbers, the columns of the first one, the rows of the second one. They have to match. In order to multiply there, those two things have to match. Now, to multiply, this is quite the process. You're going to take a row from the first one times a column from the second one. So you're going to match those up. So here we're taking 1, 3 times 1, 9, and we match them up. I'm going to write this out. You could do this hopefully in your head once you get started, but just so you can see. So we match them up. So 1 times 1 plus 3 times 9. That's going to be our first term. So we took the first row times the first column. We matched them up. So 1 times 1, 3 times 9. That's going to be first row, first column. Now we're going to move over and do the same thing. Take the first row times the second column. So match those up. So 1 matches up with 2 plus 3 matches up with negative 1. So 1 times 2 plus 3 times a negative 1. So we took row 1 times column 1. We took row 1 times column 2. And notice that's the spot they're in. Row 1, column 1, row 1, column 2. So we took row 1 times both of the columns of 2. Now we go down and do the same thing with the second row of A. Take the second row times the first column. So we match those up. Negative 1 times 1 plus 0 times 9. So that was first row, second column. First row, second column. Second row, first column, Second row, first column. Now we're going to do second row, second column. So match those up. Negative 1 times 2 plus 0 times negative 1. Now we simplify all those. This will be 1 plus 27, 28. This will be 2 plus a negative 3, negative 1. Negative 1 plus 0, negative 1. Negative 2 plus 0, negative 2. And there's our answer. Now, it probably seems logical that it ended up being 2 by 2, but that doesn't always work out the way. That's just a coincidence. You see the outside two numbers here? That will tell you the dimensions of your product, of your answer. So with the outside two numbers were both 2's, it ended up being a 2 by 2. Let's look at B times D. Again, the first thing you want to do is write down your dimensions. Well, B is a 2 by 3. D is a 2 by 3. So here they're alike. But now look at the middle two numbers here. 3 and 2. They do not match up, so we cannot multiply. This one's not possible. Even though they have the same dimensions, we can't multiply because those middle two numbers have to match. Let's look at C times E. So again, write down the dimensions. C is a 2 by 2. E is a 3 by 2. Again, look at the middle two numbers, 2 and 3. They don't match up, not possible. Okay. Let's look at this last one then, E times C. Well, let's see, E we know is a 3 by 2. C is a 2 by 2. Notice they're not alike, but the middle two numbers match, so we can multiply these. And if you look at the outside two numbers, we should end up with a 3 by 2 when we get done. So if we're multiplying that out, E times Z, again, we take a row from the first times a column from the second. So the first row is 1, 0. The first column is 1, 9. We matched up. And I'm going to write these out. You wouldn't have to if you do it in your head. So 1 times 1 plus 0 times 9. See, we took this row and this column and matched them up and multiplied and added. So that was first row, first column. Now we do first row, second column. So that matches 1 with 2 and 0 with negative 1. So we took this row, 1, 0, and matched it up with this column, 2, negative 1. 1 times 2 plus 0 times negative 1. So that was the first row times both columns. Now let's do the second row times both columns. And so row 2, column 1. Notice that goes in that spot. Row 2, column 1. So negative 3 matches with 1. And 1 matches with 9. That was second row, first column. Now second row, second column. Negative 3 matches with 2. 1 matches with negative 1. So we took row 2 times both columns. Now let's do the same thing with row 3. This column 2, 2 times this row 2, 2 with those two columns. So that matches up 2 with 1. That's third row, first column. 2 and 1 match up. And 2 and 9 match up. Now we do third row, second column. So 2 matches with 2. And 2 matches with negative 1. Probably had all those off. So there's first row, first column, first row, second column. Now we will simplify all those. Let's see, 1 plus 0 is 1. 2 plus 0 is 2. Negative 3 plus 9 is 6. Negative 6 plus a negative 1 is a negative 7. 2 plus 18 is 20. And 4 plus a negative 2 is 2. Notice we did end up with a 3 by 2. So first row times first column, first row times second column. Second row times first column, it's always we start with this one. So second row of E, first column of C. Second row of E, second column of C. Okay. The other thing on here is identity matrices. Identity matrices, they're always square matrices. Only square matrices have identities, so they're 2 by 2, 3 by 3, 4 by 4. Now if you look at this diagonal right here is called the main diagonal. Notice those are both 1s. The other two numbers are 0s. That's the way an identity matrix always looks. The main diagonal is 1s. Everything else are 0s. Main diagonal is 1s. Everything else is 0s. That's an identity matrix.